Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hey, Herman and Corn. So today's the third day of the conflict, Israel and the US fighting against Iran. And on this conflict, as in last year, we've seen that Iran has been sending a large number of ballistic missiles towards us. And thankfully, most of them have been intercepted. But not all of them. And we've talked, the Israeli Home Front Command, Pikuda Oref, has been clear repeatedly in their instructions that we have to take all the protective measures very seriously because the air defenses are, and they use this exact word, not hermetic. We've talked before about how those air defenses actually work, the Arrow series stretching up into outer space and some potentially intercepting within the atmosphere. And we've talked about the significance of the US moving its additional air defense capabilities into this area of the world. So it's truly a multi-layered and multi-force air defense system. And yet, when people go onto X and see these photos from Beersheba today, from Jerusalem, in the early hours of this morning, yesterday in Beersheba, of course, the Iranians and IRGC, a council, waste no time in using this footage to prove the futility of the Israeli air defenses. Of course, that's a very inaccurate description. And it's also misleading, I think, to see these non-saturation attempts because these haven't been the result, seemingly, of saturation efforts. Simply the fact that some of these missiles are genuinely hard to intercept. I'd like to talk today, Herman and Corn, about an aspect of the ballistic missile war picture that I don't think we've really talked about. The typical picture that we think about is we have a country like Iran launching these missiles using INS navigation systems and having a set of geocoordinates and using all this advanced sensing technology to hit the target. And that Israel simply has to see, well, there's a missile coming in very quickly. This is it. We need to blow it up between A and B. And the part of the picture that's missing from that understanding is the evasive measures being taken by the ballistic missiles. And that is what I love to talk about today. It's not simply an operation by which Iran is sending up these missiles and Israel's trying to shoot them down in a fixed or relatively predictable trajectory. Rather, the offensive missiles in the Iranian series have capabilities to detect incoming interceptors and try to evade them, even outside of the atmosphere, if I'm not mistaken. And that's what I'd love to talk about today. I'd also love to chat a little bit more. We covered this in some of our previous episodes, but the actual mechanics of these ballistic missile flights, because there's a lot of fear and almost panic here in Israel about the term hypersonic being used to describe certain missile capabilities. And we know that these ballistic missiles have certain distinct phases of their flight, from the launch phase, the exoatmospheric phase, through to the re-entry phase. And at different phases, there's different, the choice of interceptors, the logic changes a bit. And I'd love to talk about some of the most feared weapons in their arsenal. We talked about the Kheibar system being used yesterday. And Iran claims the Fattah-2 as being its most hypersonic missile. But I noted from doing some research about this ahead of sending in this prompt that experts in ballistic missile warfare dispute these claims as being more about messaging than a true accurate description of their capabilities. So Herman and Corn, I'd love to talk a bit more today when we're seeing these tragic and very unfortunate seeming failures of the missile defenses. I'd love to understand a bit more about what this actually represents. It's not just a case of missing the target. there's a whole evasive dynamic that we need to understand a bit more about. And let's talk about what unique advantages Iran is gaining from these more recent additions, because the ballistic missile arsenal is heterogeneous. It's been created over very different periods of time and very different stages of their sophistication in their aerial engineering capabilities. And it would be good, even if these are, as we always say, sobering conversations, it's good to understand the nature of the threat that we're facing against, because it puts our defensive measures in the proper context.
It has been an incredibly heavy few days here in Jerusalem. We are on day 3 of this escalated conflict between Israel, the United States and Iran, and the atmosphere in the house is definitely tense. Our housemate Daniel was actually asking us about something specific this morning while we were watching the news. He noticed that while we see all these incredible videos of interceptions, some things still seem to be getting through, or at least the Home Front Command is being very specific about the fact that air defense is not hermetic. We saw that last night with the reports coming out of the Negev and the coast.
Herman Poppleberry here, and yeah, Daniel really hit on a crucial point. Most people see the flashes in the sky, that distinct violet bloom of a kinetic impact, and think of it like a video game where you either hit the target or you miss. But the physics and the engineering behind ballistic missile warfare are so much more complex than that, especially when you consider that Iran has spent the last few decades specifically designing their arsenal to defeat the exact types of interceptors that are being used right now. We are seeing the culmination of years of iteration, from the lessons of Operation Rising Lion back in June of 2025 to the salvos being fired today.
Right, and that is what we want to dig into today. We have talked about the broad strokes of air defense before, but today we are looking at the cat and mouse game happening at the edge of space. We are going to look at the 3 phases of ballistic flight, how these missiles actually try to trick our interceptors, and whether some of these newer systems like the Fattah-2 are actually as revolutionary as the headlines claim.
It is a fascinating and, frankly, terrifying topic. To understand why a system is not hermetic, you first have to understand the journey that a missile like a Khorramshahr 4 or a Shahab 3 takes. It is not just a straight line. It is a 3-act play. You have the boost phase, the mid-course or exo-atmospheric phase, and then the terminal reentry phase. Each one of those presents a completely different set of problems for an interceptor. If you miss it in Act 1, the difficulty for Act 2 and 3 increases exponentially.
Let's start with that first act then, the boost phase. This is the launch. From what I understand, this is when the missile is at its most vulnerable in some ways, but it is also the hardest time to actually reach it.
Exactly. During the boost phase, the rocket motor is burning. This creates a massive infrared signature. Satellites can see that launch flare almost instantly. If you have an interceptor right there next to the launch site, that is the best time to hit it because the missile is heavy, it is full of fuel, and it is moving relatively slowly compared to its later stages. But the problem is geography. Iran has immense strategic depth. They launch from deep within their territory, often from underground missile cities. Unless you have ships or planes or batteries sitting right inside or next to the enemy territory, you cannot get an interceptor to the missile before the motor burns out. For a medium-range missile, that burn time might only be 3 or 4 minutes. By the time your interceptor arrives, the bird has already flown into the vacuum.
And once that motor burns out, we enter Act 2, the mid-course phase. This is where the missile is actually in space, right?
Right. For a medium or long-range ballistic missile, the vast majority of its flight happens outside the atmosphere. It is literally in a vacuum. This is where things get weird. In a vacuum, there is no air resistance. This means that a heavy warhead and a light piece of aluminum foil will travel at the exact same speed along the same trajectory. This is the stage where the defense has the most time to react, usually 20 minutes or so for a long-range shot, but it is also where the offense uses its first set of tricks.
This is what Daniel was asking about, the evasive measures outside the atmosphere. If there is no air to push against, how does a missile actually evade an interceptor? You cannot just turn a rudder or use wings in a vacuum.
You are spot on. To maneuver in space, you need what are called cold gas thrusters or small divert motors. These are tiny rocket engines on the side of the warhead or the bus that carry it. When the missile's onboard sensors detect an incoming interceptor, or even if it is just programmed to be unpredictable, It can fire these thrusters to shift its position by a few hundred meters. Now, a few hundred meters might not sound like much when you are moving at 3 kilometers per second, but for an interceptor like the Arrow 3, which is a kinetic kill vehicle, a miss by 1 meter is a total failure.
Wait, so the Arrow 3 does not have an explosive warhead? It just hits the missile?
Correct. The Arrow 3 and the American THAAD system use hit-to-kill technology. Think of it like trying to hit a bullet with another bullet. You are using the pure kinetic energy of the collision to vaporize the target. It is much more effective for destroying chemical or nuclear payloads because it ensures the whole thing is destroyed, but it requires extreme precision. If the incoming Iranian warhead fires a tiny thruster and moves just a tiny bit, the interceptor has to adjust instantly. It is a high-stakes game of geometric calculations happening in milliseconds. This is why the Arrow 3 has its own seeker head that can pivot 90 degrees to keep the target in sight even during extreme maneuvers.
But that is not the only trick they have in space, right? You mentioned the aluminum foil earlier. Are we talking about decoys?
Yes, and this is the nightmare for radar operators. Because you are in a vacuum, you can release dozens of decoys. These can be simple, Mylar balloons that are shaped like the warhead and coated in metal so they look identical to a radar. To the ground-based radar, you don't see one incoming warhead, you see 50. And because there is no air, those light balloons don't fall behind the heavy warhead. They all stay in a big cloud. The interceptor has to figure out which one is the real threat. If you have 10 interceptors and 50 targets, you have a math problem that ends in a disaster.
That is fascinating. So the defense has to use things like infrared sensors to see which object is slightly warmer, because a heavy warhead retains heat differently than a thin balloon.
Exactly. That is called discrimination. It is one of the most difficult parts of modern missile defense. The Iranians have become very good at this. They use what are called heavy decoys, or even just the spent rocket stages themselves. Sometimes they intentionally break the rocket booster into pieces so the radar gets cluttered with junk. It is like trying to find one specific pebble in a handful of gravel thrown at your face. The defense systems have to look at the micromotions, how the objects wobble or spin to guess which one has the mass of a real warhead.
So that covers the mid-course. But then we get to Act 3, which is the part that usually scares people the most, the re-entry or terminal phase. This is when the warhead comes back into the atmosphere. How does the logic change there?
Everything flips. Suddenly, air resistance is back. All those light balloons and pieces of junk, they burn up or slow down instantly. The heavy warhead, however, has the mass and the heat shielding to punch through. This actually helps the defense in one way because it filters out the decoys. This is where systems like the Arrow 2 or the American Patriot or David's Sling come into play. They wait for the atmosphere to do the discrimination for them. But there is a catch. By the time the atmosphere filters the decoys, the warhead is only seconds away from impact.
But I imagine the missile has a counter-move for that too.
Oh, absolutely. This is where we get into maneuverable re-entry vehicles, or MARVs. Instead of just falling like a rock in a predictable arc, a MARV has fins or a specific shape that allows it to glide or pull high-gravity maneuvers once it hits the air. If the interceptor is calculating a point in space to meet the warhead, and the warhead suddenly pulls a tingy turn because it has fins biting into the atmosphere, the interceptor is likely to miss. We saw this with the Shahab 3B, which uses a triconic baby bottle design to improve its lift-to-drag ratio, allowing it to steer even at Mach 7.
This seems like a good place to talk about the specific Iranian systems Daniel mentioned. He brought up the Kheibar and the Fattah-2. The Fattah-2 in particular has been marketed as a hypersonic missile. Herman, you're always skeptical of these marketing terms. What is the reality there?
We have to be very careful with the word hypersonic. Technically, almost every ballistic missile is hypersonic. Hypersonic just means traveling faster than Mach 5, which is about 6,000 kilometers per hour. A standard Iranian medium-range missile like the Kheibar is already hitting Mach 16 when it is in the outer atmosphere and Mach 8 when it re-enters. So, in terms of speed, they have been hypersonic for decades.
Right. So when they announce a new hypersonic missile, they must mean something else.
Exactly. What the world usually means by a hypersonic weapon today is either a hypersonic glide vehicle or a hypersonic cruise missile. These are weapons that don't just go fast, they stay in the atmosphere and maneuver at those speeds. The Fattah-2 is Iran's claim to this. They say it has a glide vehicle that can change course while traveling at incredible speeds, making it impossible for systems like the Arrow to predict where it will be.
And from your research, does the Fattah-2 actually live up to that? Or is it just a very fast ballistic missile with some basic maneuvering?
It is likely somewhere in the middle. From the technical analysis of the airframe, the Fattah-2 does appear to have a secondary liquid fuel motor in its second stage and a shape that suggests it can glide. However, doing this effectively requires incredibly advanced materials that can survive the heat of Mach 10 air friction for a long time. It also requires real-time communication and sensing that is very hard to maintain through the plasma sheath, that layer of ionized gas that forms around a hypersonic object and blocks radio waves. Most experts believe the Fattah-2 is a significant step up in terms of difficulty to intercept, but it might be more of a sophisticated MAR-V than a true, long-range glide vehicle like the ones China or Russia field.
That makes sense. It is about increasing the probability of a hit, not creating a magical weapon. If you have a diverse arsenal, like Daniel mentioned, you are basically forcing the defender to solve 5 different types of math problems at the same time.
Precisely. That is the core of the Iranian strategy. They don't just send one type of missile, they send the old Shahab 3s, which are predictable but numerous, to soak up interceptors. Then they send the Kheibar, which is the 4th generation of the Khorramshahr. That one is a beast. It uses hypergolic liquid fuel, meaning the fuel and oxidizer ignite on contact, which allows it to be stored ready to launch for a long time. It has a massive 1,500 kilogram warhead and can reach its target in about 10 to 12 minutes. And then, mixed in with those, you might have a few Fattah-2s that are trying to glide around the defense.
It is a saturation strategy. If you send enough different types of threats, you are looking for that one gap in the armor. And as the Homefront command says, the armor is not hermetic. If an interceptor battery has to choose between 5 incoming targets, and it only has 4 interceptors ready to fire in that specific second, something is getting through.
And that is why the multi-layered approach that Israel and the United States use is so critical. You have the Arrow 3 trying to hit them in deep space. If that misses, you have Arrow 2 or David's Sling trying to hit them as they re-enter. If it is a shorter range threat, you might even have Patriot batteries involved. But even with all those layers, the sheer physics of a warhead coming at you at Mach 12 means that the room for error is basically zero.
I want to go back to the Kheibar for a second. You mentioned it is the Khorramshahr 4. What makes that one particularly difficult compared to the older generation? I remember we touched on this briefly in episode 710, when we were talking about the nuclear threshold.
The Kheibar is impressive because of its propulsion and its guidance. It uses that 4D10 liquid propellant engine submerged in the fuel tank, which makes the missile shorter and harder to hit. But more importantly, it has an advanced mid-course guidance system. It can actually correct its trajectory while it is still outside the atmosphere using those thrusters we talked about. This means it doesn't just follow a simple parabolic arc that a computer can predict from the moment of launch. It can adjust its path to stay away from where it thinks the interceptors are.
So it is essentially a smart missile even before it hits the air.
Exactly. And it is also designed with a very small radar cross-section. They have shaped the warhead to be harder for radars to track clearly. If the radar can only get a fuzzy lock on the target, the interceptor's computer has a harder time calculating that perfect collision point. It is all about stacking these small advantages. 5% harder to see, 10% faster, 5% more maneuverable. You add those up across hundreds of missiles, and the defense's job becomes exponentially harder.
It really highlights why the coordination between the Israeli and American systems is so vital. We saw in the news yesterday that United States Navy ships were using the Aegis system to help with these interceptions. How does that fit into the picture?
The Aegis system is incredible because it provides another set of eyes and another layer of interceptors, specifically the SM-3. The SM-3 is also an exo-atmospheric interceptor similar to the Arrow 3. By having ships in the Mediterranean or the Red Sea, you are getting different angles of observation. If a land-based radar in the Negev is looking at a missile head-on, it might have trouble with certain types of decoys. But a ship-based radar looking at it from the side can see the separation of the decoys much more clearly. It is like having 2 people look at a 3D object from different sides. You get a much better sense of what is actually happening.
That makes the discrimination problem much easier to solve.
It does, but it still isn't perfect. One of the things that Daniel's prompt got me thinking about is the sheer cost of this. An Arrow 3 interceptor costs about $4 million. An SM-3 Block 2A costs nearly $28 million per shot. Iran can build a basic ballistic missile for a fraction of that. This is the classic asymmetry of air defense. The attacker only has to be right once, and their weapons are cheaper. The defender has to be right every single time, and their weapons are incredibly expensive and limited in number. We saw reports that the United States is already looking at a year-long effort to replenish the interceptors used just in the last 48 hours.
That is the grim reality of it. We are essentially trading very expensive high-tech bullets to stop relatively cheaper high-speed rocks. At some point, the inventory of interceptors becomes the bottleneck, not just the technology.
And that is why you see so much emphasis on the diplomatic and offensive side of this conflict too. You cannot just defend forever. But while we are in this phase, understanding these mechanics is so important for people on the ground. When you hear that siren and you have that 10-minute window for a long-range missile, knowing that there are literal robots in space fighting a duel at 10,000 kilometers per hour is, well, it is a lot to process.
It really is. I think what most people miss is that this isn't just about blowing things up. It is about information. The side with the better data wins. If the Iranian missile can confuse the Israeli radar for just 3 seconds, that might be enough to ensure a hit. If the Israeli radar can see through the Iranian decoys, the missile is almost certainly going to be intercepted.
Right. It is a war of bits and bytes as much as it is a war of explosives. One thing I wanted to mention about the Fattah-2, since Daniel asked about the accuracy of the claims. One of the biggest advantages of a glide vehicle isn't actually the maneuverability, though that is important. It is the altitude. A normal ballistic missile goes very high into space. Its apogee might be 500 kilometers. This makes it visible to long-range radars from thousands of kilometers away because it is high above the curvature of the Earth. A glide vehicle like the Fattah-2 stays much lower in the atmosphere. This means it stays below the radar horizon for much longer.
Oh, I see. So by the time the radar sees it, it is already much closer to the target.
Exactly. You are cutting the reaction time from 20 minutes down to maybe 7 or 8 minutes. That puts an immense amount of pressure on the crews operating the defense systems. They have to make life or death decisions in a fraction of the time. This is where the AI and the automated systems in David's sling and the arrow batteries become the primary players. No human can process that much data that quickly.
It is a terrifying thought, but also an incredible feat of engineering on both sides. I think it is important for our listeners to realize that when we talk about these systems, we are looking at the absolute cutting edge of what humans can build. It is just a shame that it is being used for this.
It really is. But understanding it helps strip away some of the mystery and the panic. When you know why the defense isn't hermetic, it doesn't make it less scary, but it makes it more logical. You understand that the instructions to stay in the shelter for 10 minutes after the sirens stop aren't just arbitrary. It is because of that third act, the re-entry phase, where things can break apart or decoys can fall.
That is a great point. The debris from a successful interception can be just as dangerous as a small missile. If you intercept a 3-ton Kheibar warhead at Mach 10, you aren't just making it disappear. You are turning it into a cloud of high-speed scrap metal that is still following a path toward the ground.
Exactly. The energy doesn't just go away, it just changes form. That is why we always tell people, even if you see the interception, stay inside. The physics of that collision are massive. We are talking about gigajoules of kinetic energy being released in an instant.
Well, Herman, I think we have covered a lot of ground here. From the vacuum of space and cold gas thrusters to the debate over what hypersonic actually means. It is a lot to take in, especially on day 3 of a conflict.
It is. And I think the big takeaway is that this is a dynamic, evolving field. The missiles Iran is firing today are not the same ones they had 5 years ago. They have learned from every conflict in the region, from the wars in Yemen to the previous escalations here. They are constantly iterating.
And so are the defenses. It is the ultimate arms race. I want to thank Daniel for sending this in. It is something we are all thinking about here in the house, and being able to break down the mechanics helps us feel a little more grounded in the reality of the situation.
Definitely. It is better to understand the monster under the bed than to just wonder how big its teeth are.
On that note, we should probably wrap up. If you're listening to this and you find these deep dives helpful, please consider leaving us a review on your podcast app or on Spotify. It really does help other people find the show, and we appreciate the support, especially now.
Yeah, it means a lot to us. We have been doing this for 895 episodes now, and the community of curious people we have built is what keeps us going.
You can find all our past episodes, including the ones we referenced today about the nuclear threshold and the logistics of conflict, at myweirdprompts.com. We have a full RSS feed there and a contact form if you want to send us your own questions.
Stay safe, everyone. Keep asking questions and stay curious, even when things are tough.
This has been My Weird Prompts. We will be back with another one soon.
Until next time, I am Herman Poppleberry.
And I am Corn. Thanks for listening.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.